Hello everyone, welcome back to my channel Sharda Devi Maths Classes. Hope all of you are fine. In the previous class, we have discussed properties of subtraction of rational numbers and have solved some questions regarding that from exercise 1b. So, let us start from question number 6 in the same exercise 1b. So, shall we start? Yes, now the sixth question is, which rational number should be added to minus 7 by 8 to get 5 by 9? So, that minus 7 by 8, that rational number, with that we are adding one rational number, we don't know that, so that let that be the required rational number. Number, and that is given as 5 by 9, that value minus 7 by 8 plus the required rational number is given as 5 by 9. So, we have to find out the required rational number. So, required rational number that we have to keep on one side. So, with that minus 7 by 8 is there. So, we have to take that to other side of the equal sign or equation. So, that is what is on the right side, that we have to write it with 5 by 9. It is minus. So, the sign changes as plus 7 by 8. Now, 9 and 8 LCM is 72 as there is no common factor. So, 72 by 9 is 8. 8 into 5 is 40 plus 72 by 8 is 9. 9 into 7 is 63. So, that is equal to 103 by 72. So, that is 1 times 72, and what is balance? That is 31 by 72. So, that is 31 by 72. Now, the seventh question, that is, which rational number should be added to minus 5 by 9 to get minus 2 by 3? That means we are adding that rational number to minus 5 by 9. So, minus 5 by 9 plus the required rational number, that is given as minus 2 by 3. We want to find out this rational number. So, the required rational number that is equal to, what is on the right side, that we have to write it first, minus 2 by 3. Then this minus 5 by 9 will go to the other side of the equal sign, then plus 5 by 9. So, that is LCM is 9. So, 9 by 9, 3 is 3, 3 into 2 is 6, then minus sign plus 9 by 9 is 1, and into 5 is 5. So, the answer is minus 1 by 9. Next is the 8th question, which is given as, which rational number should be subtracted from minus 5 by 6. So, from minus 5 by 6, we are subtracting the rational number. So, minus 5 by 6 minus the required rational number. Required rational number, that is given as what? 4 by 9, to get 4 by 9. So, which rational number should be subtracted from minus 5 by 6 to get 4 by 9. So, we want to keep the rational number alone on one side. So, this is minus. So, we want to take this to the right side. So, that will become plus. So, the required rational number that is equal to, now what is on the left side remaining? Minus 5 by 6. Now, we will take this 4 by 9 to the left side. So, sign changes, minus 4 by 9. So, what is LCM of 9 and 6? 6, 9 with 3, 2, 3. So, LCM is 3 into 2 into 3. 3 into 3, 9, 9 into 2 is 18. So, LCM is 18. So, common denominator is 18. 18 by 6 is 3. 3 into 5 is 15. Then minus and minus. 18 by 9 is 2. 2 into 4 is 8. So that is equal to minus 15 minus 8. That is minus 23 by 18. Now the answer is minus 1 and what is balance 23 minus 18 is 5. 5 by 18. That is the answer. Now the ninth question. See the ninth question from the text. That is, there is one sub question. What should be subtracted from minus 2 to get 3 by 8? So we want to subtract one number from minus 2. So at first we may write this as, let the number to be subtracted. Let the number to be subtracted be x. Like that we have to write. Then what is the question? Read again. What should be subtracted from minus 2? From minus 2 we want to subtract this x. Then what? To get 3 by 8. Read the questions 2 times. Then only we will get an idea. Then we want to find x alone. So this is minus x. So take this minus x to right side. So this is plus x. Now what is remaining on the left side? Minus 2. Then take this 3 by 2 left side. So minus 3 by 8. So this is 8 is the common denominator. 8 into 2 is 16. Then minus sign minus 8 by 8 is 1. 1 into 3 is 3. So this is minus 19 by 8. So that is minus 2 and 16. 16, 19 minus 16, 3. 3 by 8, 2 and minus 2 and 3 by 8 is the answer. Now the second part of the question is, what should be added to minus 2 to get 3 by 8? So we can write, let the number to be added. Let the number to be added be x. So that what should be added to minus 2? So minus 2 plus x to get 3 by 8. So what is x? X is equal to what is on the right side? That we have to write it first, 3 by 8. Then this minus 2 will go to the right side. So plus 2. So 8 is the common denominator. Then 3 plus 8 into 2 is 16. So this is 19 by 8. So that this is 2 and 3 by 8. 2 and 3 by 8 is the answer. Now the 10th question is evaluate. That is to find the value. First question is given like this. Here we can group like this. A rational number with the same denominator we can take at first. That is 3 by 7. 7 is the denominator there. Here also 7 is the denominator. So let us take these two at first. So that is equal to 3 by 7 minus 11 by 7. Like this together. Then that plus. Now denominator 9 is this one and this one. So we can take that as minus 4 by 9 minus 7 by 9. Now this is equal to 3 by 7 minus into minus is plus 11 by 7. Now that plus minus 4 by 9 minus 7 by 9. Removing the bracket here. So this is equal to 7 is the common denominator. So numerators we can just add 3 plus 11. Now that plus here 9 is the common denominator. So we can write minus 11 here. Now this is equal to 14 by 7 plus into minus is minus 11 by 9. This is equal to, with the 7 we can cancel. So 2 minus 11 by 9. Now the common denominator is 9. So 9 into 2 is 18 minus 11. So this is equal to 7 by 9. So 7 by 9 is the answer. Now the second question is this. Here also we can take rational numbers with the same denominator together. So this 3 and 3 we can take it first. So this is equal to 2 by 3 minus 1 by 3 together. Then with the 5 this and this. So plus minus 4 by 5 minus 2 by 5. Now this is equal to common denominator is 3, 2 minus 1 plus common denominator 5 minus 4 minus 2. This is equal to 1 by 3 plus minus 6 by 5. Now that is equal to 1 by 3 minus 6 by 5. Plus into minus is minus. So now here the LCM is 3 and 5. No common factors. So just multiply. That is 15. 15 by 3 is 5. 5 into 1 is 5 minus 15 by 5 is 3. 3 into 6 is 18. Now that is equal to difference is 13. Put the sign of the larger number, that is of 18, that is minus by 15. That is the answer. Now the next question is third. The question is like this. We can take this and this together, denominator 7. So that is equal to 4 by 7 minus 13 by 7. We can put this in one bracket. So then plus 9 is your denominator common. So same denominator is 9. So plus minus 8 by 9. Then this plus 17 by 9. That is equal to 4 by 7 minus into minus is plus 13 by 7. These two together. Then plus here also minus into minus is plus. So 8 by 9 plus 17 by 9. So here this is equal to 7 is common denominator, 4 plus 13. Then that plus 9 is the denominator here. Then 8 plus 17. The next page. So that is equal to 7 is the common denominator in the first case. Now 4 plus 13 is 17. Now that plus 9 is the common denominator in second case. 8 plus 17, that is 25. This is equal to 9 into 7 is the LCM here, that is 63. As there is no common factors in this case, it's 7 and 9. So 63 by 7 is 9, 9 into 17. So that is 153 plus 25 into 7, that is 175. Like this you have to take 25 into 4 is 100, 25 into 5 is 125, 25 into 6 is 150, then 25 into 7 is 175. Now this is equal to 8 to 3, 328 by 63. Now let us divide 328 by 63. 5 times 315. So 3, 1, 13. So the answer is 5 and 13 by 63. That is the answer. Now we will deal with multiplication of rational numbers. Here let us deal with the multiplication of two rational numbers at first. Let us take two rational numbers, say a by b and c by d. Then a by b into, you multiply this into c by d. Here a and c are numerators, b and d are denominators. So this is equal to a into c by b into d. That is the product of numerators by product of denominators. That is, multiplication of two rational numbers is equal to product of their numerators by product of their denominators. We take two examples 1 by 2 and 2 by 3 as two rational numbers, then their product, multiply that is equal to 1 into 2 by 2 into 3, then 2 and 2 cancels, that is 1 by 3, that is the answer. So the multiplication of two rational numbers is product of their numerators by product of their denominators. So now let us discuss some properties of multiplication of rational numbers. As we have discussed earlier, in the case of addition and subtraction of rational numbers, closure property is there. Second one is commutative is there. Next one is, third one is associativity. Fourth one is existence of here multiplicative identity. Then fifth one is existence of multiplicative inverse. Now one more is there, that is sixth one, that is distributivity of multiplication over addition. That is the same as subtraction also, so we can include that also. So 6 properties are there: closure property, commutativity, associativity, existence of multiplicative identity, existence of multiplicative inverse, now distributivity of multiplication over addition bar subtraction. So now let us take one by one. First one is closure property, that is multiplication of two rational numbers is always a rational number. We can show that by using an example. Say 1 by 2 and 2 by 3 are two rational numbers, then on multiplying those two, what we get, 2 and 2 can be cancelled, we will get 1 by 3. That is also a rational number. So the multiplication of two rational numbers is always a rational number. Now the second property is commutativity. According to this property, we can say if A by B and C by D are two rational numbers, then A by B into C by D, that is equal to C by D into A by B. That is multiplication of any two rational numbers is commutative. With a small example, we can take this 1 by 2 into 2 by 3, 1 by 2 into 2 by 3, and we take here 2 by 3 and 1 by 2. Here the product we find, this is 2 and 2 cancels, 1 by 3. Here 2 and 2 cancels, so this also is 1 by 3. So we can say that this is 1 by 2 into 2 by 3 is equal to 2 by 3 into 1 by 2. This is equal. So next one is third one, associativity. Then also according to this associative property of multiplication of rational numbers, if A by B, C by D and E by F are any three rational numbers, then A by B into C by D into E by F, that is equal to A by B into C by D into E by F, according to the associativity. Now the fourth property is existence of multiplicative identity. Here if you take one rational number, say A by B, then that a by b into 1. 1 into any number is that number itself. So a by b into 1 is equal to a by b. Then again, if we take 1 at first, then that into rational number a by b. That also is the same as a by b, the rational number. So a by b into 1, that is equal to a by b, which is the same as 1 into a by b. That is, any rational number into 1 or 1 into any rational number will be the same as a rational number itself. So here 1 is called the identity element for multiplication of rational numbers, that or multiplicative identity of rational numbers is 1, like that also we say. So the multiplicative identity for rational numbers is 1. Now the fifth one is existence of multiplicative inverse of rational numbers. Existence of multiplicative inverse of rational numbers. Here we take any number, say 2 by 3, its multiplicative inverse is its reciprocal, or if you take x, its reciprocal is 1 by x. Like that, if you take reciprocal of rational number, that will be 1 by 2 by 3. We know division is the inverse of multiplication, so this can be 1 into 3 by 2. So that is equal to 3 by 2. That is, the multiplicative inverse of 2 by 3 is 3 by 2. So multiplicative inverse of a by is a by b, 1 by a by b, that is b by a. So directly we can write multiplicative inverse of a by is a by b is b by a. And now if you take a by b rational number, then we know its multiplicative inverse is b by a. And if you take the product, that is a and a can be cancelled, b and b can be cancelled. So the answer is 1. So in general, we can say that the product of a rational number and its multiplicative inverse is always 1. Product of rational numbers and its multiplicative inverse is always 1. Here 1 is called the multiplicative identity. Here 1 is called the multiplicative identity or identity element for multiplication of rational numbers. Like that also we'll see. Now if you take 1, 1 is a rational number because it can be written in the form 1 by 1. So it is a rational number. Again, what is its inverse? Multiplicative inverse. Multiplicative inverse is reciprocal of 1, that is 1 by that 1, that is equal to 1 itself. So multiplicative inverse of 1 is 1 itself. Again you take minus 1, then multiplicative inverse is its reciprocal, that is 1 by this minus 1, that is minus 1, that again is equal to minus 1 itself. So the multiplicative inverse of 1 is 1, minus 1 is minus 1. What about 0? 0 is a rational number. Can we write its reciprocal 1 by 0? No. That is indefinite. So 0 has no multiplicative inverse. 0 has no multiplicative inverse. Now comes the sixth property, distributivity of multiplication over addition or subtraction we can write. So for that is if a by b, c by d and e by f are any three rational numbers, then a by b into c by d minus e by f. Multiplication, here subtraction, or we can take addition at first. Now that is equal to, we can distribute this a by b to each of these c by d and e by f. So a by b into c by d at first. Then we will write this plus sign. Then a by b into e by f. Then again we will deal with a by b into c by d minus subtraction by in minus e by f, that is equal to a by b can be distributed to each. So a by b into c by d minus a by b into e by f. So we can say that the multiplication of rational numbers is distributive, that is we can distribute over their addition or subtraction. So in the next class we will do more problems regarding these properties. So now quote of the day is, don't keep doing the wrong things over and over. Learn from your mistakes and take another approach. This is very much true when you solve questions in mathematics. Moreover, it has a philosophical touch in our lives. So keep practicing. Be blessed always. Thank you.